Okay, last section, 9.3, is connecting graphs and rational expressions. So basically what we're saying is, when you look at a graph, what can that tell you about the rational expression? So if you're looking at a rational equation, especially if you have an equation like the examples that we have here, where there are two parts to it. So normally what we would do is we would solve it algebraically, find out what our x's are, and that would be, excuse me, our answer. We're always looking for our roots, right? And our roots are always our x values for x. Our x, well, not really our x-intercepts, because it's where your two graphs cross, what is the x value. So if we look at this equation, the rational equation, it says graph it algebraically, or solve it graphically and algebraically. So graphically means you're just going to put it into your graphing calculator. So what you would do for this one, and I'm not going to do the example for this one, I'm just going to sketch it for you. But in your calculator, to do this graphically, you could do table of values, plot all your points, and then do your graph, or in your calculator, which is what you're going to do anyway because it's just that much faster. You put y1 is equal to x plus 2, put your brackets, divided by x minus 3, and your y2 is x minus 6. And I guess you don't really need to have a bracket around that one. You do around this one because we're going to do the divide. Then on your, when you're doing your calculate the second trace, you want to find that intersect. Where do those two graphs intersect? So when you do this one graphically, and you put it in your calculator, and if you want to pause and enter it in there, you sure can. I'm just going to give you a sketch of it. Your graph kind of goes, you have a straight line going like that, and then at 2 and at 8, your graph does, well, there's going to be a, whoops, non-permissible value. That's really bad. That should be going through at x minus 3, or x is equal to 3. I'm just going to erase that one. Whoops, if it'll let me. There we go. So through this point here, I would have my vertical asymptote where my denominator not equal to 0, so x minus 3. That's my vertical asymptote. And my graph kind of goes like this. And then it does this on this side. So right here at this point, and at this point, those are my x values. So based on that, I'd have x is equal to 1, and x is equal, sorry, not 1, 2, and 8. So my straight line, my x minus 6 graph, and my x plus 2 divided by x minus 3 graphs cross at when x is equal to 2 and x is equal to 8. To solve that algebraically, make sure I'm recording. X plus 2 over x minus 3 equals x minus 6. So I have to solve. I have to solve for x. So that means what I'm going to do first is a nice little cross multiply here. So I'll have x plus 2 is equal to x minus 3 times x minus 6. X plus 2 is equal to x squared. Excuse me. Minus 9x plus 18. So if I bring everything over, I have 0 is equal to x squared minus x, so that's going to be a negative 10x plus 2, so minus 2 means I'm going to have plus 16. So if I factor that, product and sum, product of 8, sum of negative 10, that means I'm going to have x minus 8 and x minus 2. If I solve that, x minus 8 equals 0, x minus 2 is equal to 0. So x is equal to 8 and 2. Now you always want to check those and make sure they work. So if I substituted an 8 in here, I'd have 10 plus 2 is 12 over 8 minus 3 is 5, right? So I would have 10 over 5 is 2, 8 minus 6 is 2, so I'm good. If I try the 2, 2 plus 2 is 4, 2 minus 3 leaves me with a negative 1, so that would mean I would have negative 4, 2 minus 6 is negative 4, left equals right, so I'm okay. So it says rational equations can be solved algebraically or graphically. Be careful extraneous roots. So that means you have to check. So let's try here. It says determine the roots of the equation 14x minus x plus 5 equals 0 algebraically. Okay. So if I have 14 over x minus x plus 5 is equal to 0. So in order to solve for this, I need to get rid of my denominator. I've got an x down there. So that means in order to get rid of this x, I have to multiply everything through by x. So x times, this is what I'm doing. So 14 over x times x is 14. Minus x times x is x squared, plus 5 times x is 5x, and 0 times x is just 0. So if I bring my left side over to the right side, I would have 0 is equal to x squared minus 5x minus 14. So product and sum, 0 is equal to x minus 7 times x plus 2. So x is equal to 7, x is equal to negative 2. I do a check. So 14 divided by 7 is 2, so if x is equal to 7. 14 divided by 7 is 2 minus 7 plus 5, and that needs to equal 0. 2 minus 7 is negative 5, negative 5 plus 0 is 0, so that one works. If x is equal to negative 2, so I have 14 divided by negative 2 is negative 7, minus negative 2, so that's plus 2. Plus 5, that needs to equal 0. Negative 7 plus 2 is negative 5. Negative 5 plus 5 equals 0. So I know that that is my solution. If I find the x-intercepts of this, if this was y is equal to 14 over x minus x plus 5. Well, to find the x-intercept, what do? Let y is equal to 0. So I would have 0 is equal to 14 over x minus x plus 5. Well, that's exactly the same thing as what I had to start with. So what is the connection between the roots of the equation and the x-intercepts of the graph that go with them? X-intercept and roots are the same thing, which if you remember is what we were talking about a few chapters back. So your roots, your solutions, and your x-intercepts all mean the same thing. They're going to solve the graph for you. Okay, let's try this one. To solve the equation, 2 minus 3x over 2 is equal to 1 plus 4x minus x squared divided by 4x plus 2 graphically. So what that means then is you can use the table of values and plug in all your points and then graph it, or you're going to use your calculator and put in y1, y2. So in your calculator then, you would have y1 is equal to 2 minus 3x over 2 divided by 2. Your y2 is going to be, and this is important, put this in a bracket, 1 plus 4x minus x squared divided by, in bracket, 4x plus 10. Okay, otherwise, your calculator is going to do, if you don't put the brackets in there, it's going to do negative x squared divided by 4x will be the only thing that will be the divide, and then it'll just be a plus 10 tacked on there. So I have just done this on my little graphing calculator here. It's not the TI one, but it's just the one that I can use on the smartboard. So you see I have y is equal to 2 minus 3x over 2, and then my second equation in red, or sorry, in red, that was my red equation. My blue equation is with the brackets 1 plus 4x minus x squared over 4x plus 10. So then, in order to find out what my roots are, I need to find out, okay, what are those points where my two graphs crossed? So one of those points is right here, which is at negative 3.34 for the x. The y is 7.01. We don't really care about the y. That's not giving us what our solution is. That's not giving us our x value. The other one here, and you have to watch, especially on this one. On yours, it'll calculate it for you, but on this one, there's actually two dots really close together. So one of them is at 1.14, and the next one, oops, is at 1.41. If you notice, that one is a little bit off my graph, so that's why I go with this one, 1.14. So my two solutions graphically are negative 3.34 and 1.14. So x is equal to negative 3 point, and it said to the nearest hundredth, which my graphing calculator did, and the other one was 1.14. So it says verify your solution algebraically. So there's two ways of doing this. Because I know this is my solution, I could substitute those values in there, but this question is saying, don't check it. Show me that this is right. So that means that I have to go through the process of solving this. So I have 2 minus 3x over 2 is equal to my 1 plus 4x minus x squared. And on the bottom, I'm going to change this into 2 times x plus 5. So that means that what I need to do is I need to get rid of my denominator, like I did in that other example. My lowest common denominator, I have a 2. And I also have x plus 5, so that should be 2x plus 5. So that means I have to multiply everything through by 2 times 2x plus 5. So I'm going to multiply this side of my equation and this side of my equation by 2 times 2x plus 5. I'm just going to move my b here so I can... So I'm going to multiply this by 2 times 2x plus 5. Okay, so if I multiply each term, 2 times 2x plus 5 times 2, so that's like 4. Oh, I'm going to go back to blue, so that's going to be 4 times 2x plus 5. 2 times 2x plus 5 times 3 minus x over 2. Well, this 2 and 2 will cancel, so what I'm left with is minus 2x plus 5 times, ooh, that's fancy, 3 minus x equals. So now on this side, 2 times 2x plus 5 times 2 times 2x plus 5, well, those are just going to cancel each other. So I'm left with 1 plus 4x minus x squared. So what do I have here in this mess? I have 8x plus 20. Well, that's not a 3 minus x, that's just a 3x. Right here. So negative 3x times 2x plus 5, that's going to be negative 6x squared. Negative 3x times 5 is going to be negative 15x, and that equals 1 plus 4x minus x squared. Okay, so what do? Bring everything over to one side. So on this side, let me simplify here first. I have 8x minus 15x, so that's going to be negative 7x. Minus 6x squared, I have nothing I can do with that, and plus 20, nothing. Okay, so now I'm going to bring over minus 7x, so I'm going to add 7x. Minus 6x squared, so plus 6x squared. And then plus 20, so minus 20 should go right there. Okay, so I have on this side 0 is equal to, I'm going to put this in order now. So negative x squared plus 6x squared, so that's 5x squared. Plus 4x plus 7x is plus 11x. 1 minus 20 is negative 19. So you can try to factor this using slide and divide. It's going to take you a little while because you're still going to end up with some pretty wild numbers. So the easiest way to do this is that quadratic formula. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So if I substitute in here, x is equal to negative 11 plus or minus square root 11 squared minus 4 times 5 times negative 19 all over 2 times 5. So when you calculate this, you're going to have to do negative 11 plus, blah, 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 and then negative 11 minus, blah, 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 blah. You get your answer to be x is equal to negative 3.34 and 1.14. Done. Okay. So this says, solve the equation x plus 3 over 2x minus 6 is equal to 2x minus x over 3 minus x algebraically and graphically. So, algebraically, in your calculator, y1 is equal to x plus 3 divided by 2x minus 6. y2 is equal to 2x, bracket 2x, minus, bracket, x, divided by, bracket, 3 minus x, close bracket, only because you didn't really need this first bracket there. You can leave that one off. So this will be a 2x minus, bracket, x, divided by, bracket, 3 minus x, close your bracket. So that's how you would do it graphically. Put it in there, do your second calculate, intersect, find x intersect for those two graphs, or where the two graphs will cross, and you'll get your two answers. Possibly two answers. You might find out when you look at the graph, though, that there could be just one answer to this. Algebraically, then. So I have x plus 3 times 2 times x minus 3, so I've just factored that, is equal to 2x minus x over 3 minus x, which is the same as negative x. Whoops. If I GCF a negative from there, it would be a negative x minus 3, right? If I take a negative out of here, this 3 becomes negative, that negative x becomes positive. So my common denominators then are going to be 2 times x minus 3. So that means I need to multiply my top and bottom on both sides by 2 times x minus 3. So on this side, my 2 and x minus 3 and my 2 and x minus 3 are going to cancel. So I'm left with x plus 3 here. On this side, I have 2x times 2, so that's going to be 4x times x minus 3. And on this side, my x minus 3 will cancel with my x minus 3, and I'm left with that negative, or the 2 and the negative. So I'm going to have a negative 2x over, if you want to leave it as negative 1. And you'll see this is going to change my negative divided by a negative there. So what I have is x plus 3 is equal to 4x squared minus 12x. because 4x times 3 is negative 12x, and this becomes plus 2x. So if I bring everything over, I'm going to subtract x, and I'm going to subtract 3. So I have 0 is equal to 4x squared minus 12x plus 2x, so that's negative 10x minus x is a negative 11x minus 3. So again, you can try slide and divide. Let's see if that one works. So this would leave me with 0 is equal to x squared minus 11x minus 12. So I multiply by 4. If I factor, that's going to be x minus 12 times x plus 1. So then I divide by 4, so this is x minus 3 times x plus 1/4. And because I'm solving for this one, I'm not just finding the factors I'm solving, I don't have to multiply by 4 to get 4x, because then just to solve it anyway, I would have to divide by 4. So I have x is equal to 3, x is equal to negative 1/4. So now I have to check and see if these work. What you could do also here, if you didn't want to do slide and divide, is that quadratic formula. Or this was an easy one to slide and divide with, so it worked all right. So I have to do my check. If I take a look at this, right in here, in this step right here, my denominator, I had an x minus 3 and an x minus 3. So I could put both of these in here and solve it, or I can take a look at my denominators and say, well, in my denominator I had x minus 3, so that means I have a restriction. X minus 3 cannot equal 0. X cannot equal 3. Well, that's one of my solutions here. So if you were to check this, and I'll just do it over here, if I check this, I would have 3 plus 3 over 2 times 3. I'm going to just actually multiply that. So I have over 6 minus 6 equals 2 times 3 is 6 minus 3 over 3 minus 3 is 0. So I have 3 plus 3, so 6 over 0 equals 6 minus 3 over 0. Well, right away I see a mistake because I can't do this. So if you didn't catch that right away, that you have in your original equation, you have NPVs, that could be how you get rid of it, see what your restriction is, or you can actually do the solve, put both of those in there. So this is your solution, x minus 1/4. So this one here, when you would have done it in the graph and done your second intersect by doing it this way, you would have seen that there's only one spot where that graph crosses, and it's at x is equal to negative 1/4 or negative 0.25. Example 4, it says, Megan and her friends are organizing a fundraiser for the local children's hospital. They are asking local businesses to each donate a door prize. So far they have asked 9 businesses, but only 1 has donated a prize. Their goal was to have 3/4 of the businesses donate. If they succeed in getting every business to donate a prize from now on, how many more businesses do they need to ask to reach their goal? So what they're looking for is to have 3/4 of the businesses that they ask give them a prize. So their goal is based on their success divided by how many requests they make. So if their goal is 3/4, their success rate so far has been for every, or 1 store or one business has donated for every 9 they have asked. So how many more do they have to, successes do they need in order, oops, that should be a 9. So they have started with a 1 out of 9, so how many more of each of these? So they're going to increase it. The more they ask, the more they're going to get. So in order to solve this, you're just going to have to do a cross multiply and solve. So 3 times 9 plus x is going to equal 4 times 1 plus x. So I have 27 plus 3x is equal to 4 plus 4x. So if I bring my x's to one side, if I subtract my 3x, subtract my 4, I have 23 is equal to x. So that means they need to ask 23 more businesses in order to have a 3/4 success rate. And you can check that. So 1 plus 23 over 9 plus 23. So that gives me 24 out of 32. 8 divides into both of those. 8 is 3 over 4. So they need to ask 23 more businesses. Pretend that says businesses. That's it. Guess I should just go over the key IDs. You can solve rational equations algebraically, so that's solving, finding what your x equals when your y is 0, or graphically by putting it into your calculator and calculating that intersect. The solutions or roots are equivalent to the x-intercepts of a graph. You can use either of the following methods to solve it. Manipulate the equation so one side is equal to 0, then graph the corresponding function and identify the values of the x-intercept, or graph the system of functions that correspond, so that's that y1, y2. So what I could have done too, and I didn't do it in the other examples, because it's just easier with your graphing calculators to do y1, y2, is I could have moved everything over to one side of it so that I just had y equals, and then if I did it that way, if I had everything on one side of the equation, then what I would do is I would look for my, instead of my x-intercept, I would look for my, what was the other one on there? There's the intersect and the, well, I can't think of it top of my head, but I would use the second one that we've always used for solving. Okay? It's easier if you do it y1, y2. There's a lot of math involved in getting everything over to one side of the equation, and there's a good chance of making a mistake. Okay, and then it says, when solving rational equations algebraically, remember to check for extraneous roots and verify your solution does not include any non-permissible values.